Now let's look at another question. Given an array of number k, and we need to find the kth smallest element in the array. All the elements are distinct in the array. Okay, so kth element is at index 2. Okay, so the k is 3, so it means index 2. So how can we find it? The intuitive approach for me is to first sort the array and just look up at its index at k minus 1. For example, we can draw an example here. After sorting, this will be 10, 15, 20. Kth element is here, 1, 2, 3, k. So this is an index 2. We can sort in place using Python's list.sort. And after we sort it, we can just return a and k minus 1. The time complexity of this approach is O of n log n because sorting takes this time, and space complexity is O of 1 because we are sorting in place. Okay, so can we do better? We can do better here. And so we are looking for the smallest. So the kth smallest is so Python has a heap built in, but it's a min heap. And here, since we're looking for the smallest, we should use a max heap. And since we can just convert finding smallest to finding largest, let's convert it first. Okay, so this is first approach, and second approach, I want to try a heap. So 3, 4, 5, and this is n. 1, 2, 3, 4. So the second smallest is the fourth largest, and n minus 2. So n is 6. The array of lengths, n is the length of the array, and it's 6. So 6 minus k equals 3. The array we're looking for is at k minus 1, index k minus 1. And it means it is the fourth largest element. So fourth largest. 4 is n minus n minus k is 3 and plus 1. So the question becomes, let's find the n minus k plus 1th element. N minus k plus 1 largest number. N minus k. Yeah, looks weird, but I think it's right. Okay, so we can heapify the whole array, which takes O of n time, and then we can pop. Okay, let me just put it into another number. So let me call this m. Oh, okay, what's this? Okay. What happened here? Let's just call this x. And then we need to pop x time. X times to find the x. The x sounds weird. T. Teeth. Teeth. Okay. So okay, we will pop t times to find the teeth largest number. And we will get the value of the teeth element, which will be our return value. Okay, so let me write some, okay, so pop t times, it means t times log n, because every popping takes log n times. So pop t times is t times log n plus this on. So this equals, not equal, but this time complexity is if we, so t log n, and the t is kind of equivalent to k, because we don't know if k is larger than the half or smaller than the half of the array. So it is just k log n. This this time complexity is better than this one, and the space complexity is space is O of n, because we have converted to a heap of n elements, which is an array of length n. So yeah, if space is not a problem, then I think this is a good approach. But if space is a problem, then it's better to use this approach. Or there is another way to implement the heap method, is to make a heap of size t. So we keep pushing elements to the heap, and when it exceeds the number of t, we start to pop out the maximum item. So then the time complexity becomes, so it's a heap of t items. Okay. The time complexity is so for example, t is 2, then the size of the heap is 2. So every time we swap something or we pop something, the time complexity is log t. And we have to do it n minus t times. So since t can be pretty small, so we can just ignore this is approximately still n. So n log t, O of n log t is time complexity, and O of t is space-time time complexity. So comparing to the approach number 2, where we constructed a heap of n items, this time complexity is not as well as this one, because n might be very big, so we put n in the log and it will give us a much smaller, much more efficient time. And like this, if t is pretty small, then it's still like n log n. I mean, if t is very big, then for both approach 2 and 3, it's approximately still n log n. But if t or k is not very big, then the second approach has a better time complexity, but the third approach has a better space complexity. Okay, since I think nowadays we have plenty of space, so I'm going to implement the second approach. A stands for array here. So first we want to import heap cube and heap cube dot heap p5. So now we have a heap. We store it somewhere. Now we can pop the teeth element. Okay, t equals minus k plus 1. Yeah, actually the fourth element. So we are looking for the teeth largest. That means, for example, if we want to try to find the teeth largest, the fourth largest, 1, 2, 3, 4 is at index 2. Oh, why is that? Fourth at index 2. So I'm not quite sure about the number, but you get the idea that we want to pop. So for example, we want to find the fourth largest. So we do need to pop 4 times, right? Yeah, I think it's right. Yeah, that's it. Thanks for watching. Bye bye. By the way, there's another approach. It's more complicated to write. Is quick select. I'll take another video to write that out, but maybe after this assignment. Sorry, I made some mistake, and so first the heapify transform list x into a heap in place. So instead of storing this in another variable, we don't we shouldn't do. Just do this. And also the pop is should have a hip here. Hip hop, okay. Hip. Oh, so okay, so it is still the list. Yeah, because in Python heap is just a list. Okay, yeah, I think that's right now. Thank you.